Alrighty, in this video we're going to be looking at the addition rule, in particular for probability. So at the moment we've got the rule just here, and it'll make more sense once we go through an example or two of applying it and using it to solve various things. But the rule essentially says that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. In layman's terms, it means that add A's and B's together and take away the ones that you've double counted, things that are in both sets, and you obviously don't want to double count. So let's have a look at an example. Consider the set 1, 2, 3, all the way up to 20. So we've got positive integers up to 20. I'm going to say set A, we're going to say let set A be the set of all multiples of 3. Okay, so we're going to have 3, 6, 9, 12, 15, and 18. The next one being 21, which is outside my original set, so I can't have a subset bigger than 18. And I'm going to say set B can be the set of all prime numbers within this larger set. So set B, we're going to have 2, 3. By the way, I'm not starting with 1 because 1's technically not prime, but that's a different video. 2, 3, 5, 7, 11, 13, not 14, not 15, not 16, 17, and 19. Okay, so we've got our two sets there, set A and set B, and we're going to get asked to solve for two things in this case. We want to find the probability of A intersecting with B, and we want to find the probability of A union B. So A intersect B is just going to be by inspection. We're going to look at these two sets and see which numbers or number is in both of these subsets. So I'm going to start with a smaller set. Doesn't make sense to start with a bigger set. We'll start with the smaller one, see what transitions over. Now, this one's nice and easy because these are all multiples of 3. So inherently, none of them are prime except 3 itself. So 3 here can be found also down here in this subset. 6, 9, 12, 15, 18, because they're multiples of 3, can't possibly be prime, and hence we only have one term or value in each set that is the intersection. And hence, this probability is just going to be that 1 divided by the total number in the major set, which is 20. Okay, so the probability is simply 1 out of 20, 1/20th. Now, part 2 is where we actually use this rule. So we have the probability of A union B, which is what we're asked to solve for, is probability of A plus probability of B minus the probability of the intersection. Now that intersection we just found, 1 in 20 numbers, or 3, is the only number that is going to be the intersection. So we're going to say this is going to be equal to the probability of A. Now, the probability of picking a number from set A, if I picked randomly, would be 1, 2, 3, 4, 5, 6 out of the 20 possible numbers. So that's going to be 6 out of 20, plus we need the probability of B, which is going to be 1, 2, 3, 4, 5, 6, 7, 8 out of 20. And you can see that if we just stopped there, if we put all the A's and the B's into a big pile and said that's the probability of getting A union B, what we've actually done is we've double counted this 3. We've counted it as part of this 6, and we've also counted it as part of this 8. And because we've double counted it, we have to take one of them away. And that's where this minus the intersection comes from. So we're going to subtract 1 over 20. And now we have a common denominator. So the answer is going to be over 20. And we need to just simply add these terms. 6 plus 8 is 14, minus 1 is 13 out of 20. In our second example, we've actually been given some probabilities, so we don't need to calculate them ourselves. However, we do need to use them in order to solve and determine the probability of A intersecting with B. So this time we're still going to be using this formula because we've been given probability of A is 0.4, the probability of B is 0.8, and the probability of A union B is 0.85. So we have this element, this element, this element, but we're missing this guy. So it's really just a case of substituting in the known values and rearranging your equation, but we do have to use that equation. So I'm going to substitute what I know into this equation from these elements. So the probability of A union B is this 0.85. So I'm going to start with 0.85 must be equal to the probability of A, which is 0.4, plus the probability of B, which is 0.8, minus the probability of the intersection between them, and that's just going to have to stay as it is, because that's what we're trying to solve for. So from here, we just need to simplify and rearrange. So first thing I'm going to do is add these two terms together. So I'm going to get 0.85 is equal to 1.2 minus the probability of A union B, A intersect B. And now we're going to add this probability over here and subtract 0.85. So the probability of A intersect B is going to be equal 1.2 minus 0.85, and hence the probability of A intersecting with B is going to be 0.35. Okay, and that's second example done. That's all I'm going to leave you with in this video. Hopefully that helped you understand this addition rule a little bit more and some applications that you can use to solve equations.